to push it to Google Drive.
Okay, are we recording?
Yeah.
Okay.
I see that.
All right, so monitoring. There's quite a lot of components to it.
Shocking.
So here I listed all the components that we actually install somewhere. We have a bunch of stuff that we use externally. Some of these are all part of the Prometheus suite. So like Alert Manager, Prometheus, and the Push Gateway are all components of Prometheus itself. Grafana is our fancy dashboard that we all know and love. MTell is a component that we use to monitor our logging, and it will generate metrics based on very fancy regex, which is amazing. That's produced by Google, I think. We got a component called Thanos, which I'm not 100% familiar with, which is what drove the creation of this issue. Trickster, which I learned is new. We have many exporters for various services. We create our own. Our applications export metrics. Prometheus is geared towards scraping all of them. And then we still have Flux DB and a relay sitting in our environment. So I'm just going to kind of roll through what I've discovered. And if you have questions, feel free to stop me and try to figure out what in the world I'm talking about. But as far as the alert manager goes, this is responsible for sending alerts in all shapes of sizes and forms everywhere. I decided not to dig into precisely how rules are set up because we have so many of them. But the alert manager is configured to send alerts to various places. PagerDuty and Slack are the primary locations for those. And based on the type of rule, will determine the severity that PagerDuty or Slack reacts upon. An alert manager is set up in a redundant fashion. So we've got two nodes sitting in our production environment. We've got two nodes sitting in ops. And because we still have some infrastructure in Azure, we have an alert manager sitting in the Azure environment as well. What I thought was kind of interesting is how Prometheus actually operates with the alert manager. So it's the job of the Prometheus service to reach out to an alert manager to determine how an alert gets sent out. Prometheus will simply send the data to the alert manager. It's up to the alert manager to send the alert. So in the production environment, for example, he knows of 4 total alert manager servers. He picks one and the alert just goes out in some way based on how the alert manager service is configured. Staging, for whatever reason, will only use the production alert managers. The disaster recovery environment uses production alert managers. The pre-environment uses both production and ops alert managers. Testbed uses both as well. And ops will only use production alert managers. So I find it kind of weird that we've got it configured this way. I have an open issue to discuss how we got to that point.
Wait, Scarver, just one sec. We have ops using production alert manager, and we have pre-using production and ops alert managers.
Yes.
And we have staging using production alert managers.
Yes. I created an issue to figure out why we landed this way. I did not look into commits to figure that any further because I didn't want to sit there and, dream over it, but
okay, that is really confusing.
It's a little odd. I know at one point in time we had a desire to move as much monitoring as possible into the ops infrastructure, and I wonder if we're just in the middle of that. But I never saw an issue to discuss that comment, so I can't validate whether that's true or not, or if it's something I made up when I was dreaming. Welcome, Jarv. So, yeah, that's the alert manager.
Okay, that is extremely confusing.
Yes. So Grafana, we've got 2 dashboards. You probably know this, but dashboards.com and dashboards.gitlab.com and dashboards.gitlab.net. .com is the public-facing one. Anyone could see any metrics that specific instance has access to. People supposedly cannot modify and create their dashboards, or rather they would not be saved if they were trying to create dashboards. .net is our internal one. All the developers could log into it. They could create dashboards. This is where dashboards that we create live. and they get eventually copied over via some process that syncs them between the two instances.
What is the process? Do you know?
Yes. So there's a recipe that, this is going to be in my way. We've got a script that gets installed called literally sync Grafana dashboards. It's just a small Ruby script that will take what's on one instance and shove it over to the other using the Grafana API.
Okay.
Kind of nifty. We create dashboards automatically via our runbooks. So we have a job inside of our GitLab runbooks project, and it will take, we got a small shell script. It looks through a directory that we've got sitting inside of here, or excuse me, where is that directory at? Dashboards. So it's just a bunch of libsonnet files that creates a lot of dashboards. Andrew's been the primary person for this. And we have a CI job that will sync those up to the .NET instance.
We also have JSON in our environments.
Yes, of course.
Great.
Why not?
That's amazing. I'm really happy that we standardize on something.
As far as data sources go, this is where things are a little, I wouldn't say hectic, but they're a little difficult, I would think. Dashboards.com only has access to application metrics for staging and production. Infrastructure-wise, it has metrics for staging, production, and the ops environments. All of the data sources are created manually. This is a known thing, and I'm pretty sure Ben has created an issue to address this in the future. For internal, I'm pretty sure the same exists. But we have metrics coming from many, many places. So Thanos Query is one location, and I'll get to Thanos Query and what that is later. We got an Elasticsearch data source for our production environment, as well as some of our abuse cluster stuff. I don't entirely know what all that entails. We got Influx DBs for staging and production. Metrics are exposed from a service called SiteSpeed. I never looked into what that is, but I think other people know that it's constantly measuring the speed of our website in some form.
Yeah, I didn't look into it. Or something like that, if I recall correctly. Okay.
Probably similar to webpagespeedtest.com or whatever. We have infrastructure environments for the staging, production, disaster recovery, ops, pre, and the testbed environment. And we have application metrics for all those except testbed, which I thought was kind of interesting, but that's probably just a small oversight. And I'm pretty sure all these data sources are entered into that instance manually. So anytime this instance needs to get rebuilt, someone needs to go in there and change it, which I think kind of sucks because that happened recently to the dashboards com instance, which really sucks. So InfluxDB is another component. We've got 4 nodes. They all serve as database servers. We have 2 of them in staging and 2 of them sitting in production. As far as I know, just the WebGet API and Sidekick fleets actually talk to the InfluxDB relay, which is installed on those servers, and the relay will push the metrics to InfluxDB.
Wait, why are we using InfluxDB? I thought we removed that, or we don't use that anymore. Do you know?
I do not know.
Jarv, do you know? I thought we stopped using Influx.
No, we still use InfluxDB. It came up during the migration, but there was some back and forth, and we decided to keep it because there were some things that we only have in InfluxDB that we want to monitor.
Maybe it's something where we have a few metrics that maybe we only care about a few of them and they just haven't been ported over yet. I don't know, because I felt the same about what you're asking. So
okay,
they're still there. And there's still a data source. I don't know what dashboards pull that information. I'd have to look into that at some point. MTell, another component mentioned earlier, this looks at our log data, and there's I use the word amazing regexes. So there's a cookbook literally called GitLab MTell, and this is where we store all of our configurations for the amazing regexes that generate our metric data. So these are pretty complicated. I don't know how we test this, but somehow we do. But it makes it out there, and it becomes a scrapable endpoint for Prometheus. Thank you, Jarv. Prometheus. This one is pretty complicated. We have, I don't know how to quickly discuss Prometheus. I'm going to...
You don't have to quickly discuss it. Go for it. Start and let's see where it ends.
Okay, Prometheus, responsible for scraping metrics, responsible for sending metrics to the alert manager so he knows how to alert things. We have many, many jobs across a few different types of Prometheus instances. So we have 3 Prometheus types. We have simply called Prometheus, we have Prometheus app, and Prometheus DB. The Prometheus DB servers are only located in production and staging. The other environments like ops, disaster recovery, and they only have the Prometheus and Prometheus app instances. So from what I could tell, all of our jobs are in Chef. So there's roles that define all these scraping jobs. I did find some inconsistent configurations. So like we have Prometheus DB, but we have all this stuff related to monitoring our database stuff inside of the Prometheus app instance, which I thought that was kind of awkward. But Prometheus is pretty, it does a lot. Its configuration is pretty convoluted, but it's easy to determine what it does because everything is in Chef and it's very well configured from what I could tell. It just, there's some inconsistent configurations in there. I have an open issue to figure out how we got to where we got, where the app instance is pulling some database information out of it. We even have some application metrics being carved out of the non-app Prometheus instance. I guess before I continue, do you have any questions about that? Because I don't know how to go into any more detail about Prometheus.
No, I think I didn't know that we have 3 separate instances, but the rest I understand what it is.
Yeah. So just to be clear, like all these Prometheus instances, they store data locally as well as pushing them to the cloud. Or excuse me, Thanos is what pushes it to the cloud, I believe. But the DB is not just the database backend for Prometheus. It's actually just a scraper that does the same thing the other Prometheus instances do. I had that misconception when I started looking into this, so I'm glad I did this. We also have a couple Prometheus instances dedicated for our runners. So we got 2 of them sitting in the GCP project and the CI/CD project. And then we've got 1 sitting in the DigitalOcean project, but it's probably not scripting anything because I'm pretty sure we don't have that turned up right now.
We don't, yeah.
Yep. Okay, so exporters, we have a shit ton of them. Alert Manager has its own endpoint for scraping metrics. So, you know, Prometheus has a way to figure out whether or not we are actually able to alert or not. We have an alert to tell us whether or not we're alerting or not, which is pretty funny. Blackbox is a Prometheus component. It's primarily used for scraping things that we need from an external endpoint. So like we would scrape our, kind of like what we do with Pingdom, but for Blackbox. It's just a service that we run and Prometheus scrapes it. FluentD is a kind of an interesting one. Instead of running a dedicated service that runs an exporter, it's actually a plugin into FluentD made in Ruby. And Prometheus will scrape any data that the FluentD service provides us. CAdvisor, for some odd reason, we have this only on our GitLab nodes. So I don't exactly know what metrics we're getting out of CAdvisor that we don't get out of, say, our node exporter. GitLab also has its own...
Wait, what is... I don't understand what CAdvisor is supposed to be doing. It's supposed to be a node exporter-like thing only for GitLab, though, right? I'm not following.
So CAdvisor was first created as a method of gathering various system metrics when Docker was first created. I don't know why we would be using it at this moment in time.
We probably use it on the file nodes because we have C groups on the file nodes or GitLab.
Okay, that makes sense to me.
Okay, that makes sense. Yep.
Is GitLab the only place where we heavily use C groups?
I think it's the only place
so.
we use C groups at all.
I think we are only using C groups there.
Okay, that makes sense to me. We also have something called GitLab Gitly. I don't know what it actually is, but it's also installed alongside the C advisor in the same chef recipe. I forgot to do further investigation on this, so I feel uneducated about this, so my apologies. But this is something else that gets installed in all the Gitly nodes. I completely forgot to circle back around to that. That sucks. I'll have to do that at some point. Node Exporter is exactly what it sounds like. It exports a bunch of metrics that are specific to whatever is running on that node that we configure. This gets installed on pretty much every single server that we run. Postgres related metrics, we have a few different things. So Postgres has its own exporter. We use the community provided one for this. We have one dedicated for PG Bouncer. Again, that we're using a community provided one. And then we have a project called GitLab Monitor. I learned about this. This is new to me. But this is monitoring a few items for the Prometheus database stuff that I guess either Postgres or PG Bouncer exporters do not provide. So database bloat, database mirroring, the row counts. I guess we have something specific to CI builds, remote mirrors. All of that is built into our GitLab Monitor project, and apparently GitLab Monitor is something that we also ship to our customers via the Omnibus package. So that was kind of interesting to learn about. GitLab Monitor also provides us with some process metrics, but I didn't look into what those process metrics are and why we don't have stuff defined in there provided by like the node exporter or process exporter. But lost my place. Okay. But we also use the process exporter provided by the community. This is also installed on nearly every server. I think the only place where we use this heavily is our HA proxy boxes at this moment in time.
Sorry, what does it do?
It looks at processes that you configure and gathers various metrics about it. So HA proxy, for instance, we want to make sure that we're only running a specific number of those instances. We want to monitor the CPU usage of the HA proxy processes. So it exports stuff like that.
This came about because of the problems with HA proxy being single-threaded back when we were running the single-threaded version, and that it would just like use like max CPU on a single core, and then we would have performance problems. So we added process monitor so we could monitor it a bit closer. Now we have multi-threaded.
Now we have multi-threaded HA proxy running. I think Jar wanted to say.
Yeah, Jar has frozen. Oh well. I'll move on. The push gateway. This is a Prometheus project. This allows us to create an instance where we are able to send metric data to it, kind of like what Flux DB is for. We have this installed on every black box instance, just because we didn't want to create a separate node for something that's not going to be used very heavily. I can't recall off the top of my head how many services actually use this. It's not many. I'm pretty sure Andrew set up a few services that send metrics to it, but it's not heavily utilized. Stackdriver exporter, we want to make sure that we capture all the metrics that GCP is providing us. So we got a dedicated node set up to monitor all that stuff. GitLab itself, we know has its own ability to generate metrics. So here's a list of all the port numbers and services that generate metrics for.
I'm a bit surprised that we are actually using those. But I guess it's good.
Why are you surprised?
I don't know. I thought everything. Oh wait, is this is individually set up? This is not outside in the package. We're not using the one that we're shipping with the package, right?
We are.
We are?
From what I could tell, yeah.
That's why I'm surprised mostly, because if I recall correctly, some of these things were set up prior to us shipping this in the package. But if we are using it, that's actually pretty good.
Yeah.
Okay, well, that's good.
I think the one that I want to highlight out of here is the unicorn one. This one, when I was doing my investigation of this, as well as when I was hopping on one of our recent incidents, unicorn would constantly time this endpoint out. It would constantly take over 10 seconds. And it makes me think we're losing some metric data because of that. But Andrew made it seem like this was a very well-known problem and that there's an issue somewhere to address it. So I thought it was interesting. Okay. HE Proxy Exporter, this is dedicated to gathering HE Proxy metrics out of the socket that the HE Proxy admin interface provides. Already talked about MTell. And Prometheus exports itself, so it scrapes itself to determine whether Prometheus is running or not, which is pretty fun. The Redis service, we use the community-provided Redis exporter, and registry has its own metrics interface when you enable it on one of the debug port on 5001. So we try to. I feel like we have excellent coverage as far as scraping as many metrics as we possibly can. Whether or not we use it to the fullest extent possible is a different story, obviously. The other thing I wanted to talk about was Thanos a little bit, because this is where I was getting frustrated, which is what drove the creation of this issue. Thanos is relatively new to the world in general, like it's on version 0.050 at this moment in time. This serves a few purposes. One, it allows us to connect multiple allows us to create a single interface for which we could send queries to gather data from multiple Prometheus boxes throughout our environment. It sends our data to the cloud for long-term storage and allows us to be able to query that long-term storage quickly without needing to store or cache that data locally for long periods of time, so that we're controlling our disk space usage. And it also allows us to actually modify what's in long-term storage. That way we are not blowing up our cloud storage bills. So the few components, Thanos Query is one of them. This is what allows us to connect to various Thanos Store instances. The query is the endpoint where we would send queries to. So Grafana would use Thanos Query as the data source for itself. We only have one of these. It sits in the ops instance, and it is configured to look at every Thanos box that we have in our environment. And we've got the network peering in GCP set up to cross various projects to allow this to work. The Thanos query is going to connect to the Thanos Store instance. The Thanos Store is what connects to the location of where we could find data. So that could either be object storage, or it'll connect to a Thanos Sidecar. When the Thanos Store receives a query, I guess somehow it's got magic programmed so it knows how to interpret that query, so it knows where to find the data. So if you send it a query for old data, it somehow knows to look at object storage. If it knows the data is supposed to be from 5 seconds ago, it knows to go look at the Thanos Sidecar for the data. I'm going to skip the compact. The Thanos Sidecar is what runs next to Prometheus. So for every Prometheus box, we have a Thanos Sidecar service that runs. It actually looks at the data that Prometheus has dropped on disk. We'll peel that data and serve it up as a method for querying that data. And then it also has a secondary process for sending that data to object storage for long-term storage. So when we make queries inside of Grafana, we're not talking to Prometheus unless we have our data source set to Prometheus. If we're talking to Thanos Query, all those queries that go there will hit the Thanos Sidecar in our environment.
Okay, few questions. You say that when we load our dashboards, we go to Thanos Query. Did I understand that correctly? We go to Thanos Query first.
That's one of our data sources. So if we have that configured for that query, then yes. But you can configure multiple data sources on the dashboard.
Okay. Is that easily visible? Sorry, I don't know.
If you mildly easily, it's not. When you edit a chart, yes, it's visible. I'll show you real quick.
Okay.
So if we edit the 5x responses.
Yeah, okay, that I know.
We have it set to global. Global is the Thanos default. I don't know if I'm logged in or not, but if we go data sources global, we're talking to
Thanos. Okay.
If you could read that, it says Thanos Query.
Yeah.
So yes, for that particular chart, we're going directly to the Thanos Query, which means we're querying only Thanos in our entire environment. We're not querying Prometheus directly in that case.
Okay, so when we say we are not seeing anything on the dashboard, Thanos is down, Thanos Query is down then.
Either Thanos Query down, or there's like some underlying Thanos that's down somewhere inside that query is trying to reach out to that it can't get to.
Okay, I get it now. So it can be any of these, making it super simple to find. Okay.
Yeah. I think this is where we need to improve some of our monitoring, because I think it's happened a few times in the past few months where metrics don't show up and no one knows about it.
Yeah, it's past 2 weeks.
When you start
actually
monitoring our Thanos Query instance.
So we are not monitoring those yet, no?
If we are, I don't know about it.
Okay. So we have a new component in there that is a bit of a black box for us at the moment.
Potentially. Me driving this information is hoping making it less of a black box, but yes.
Yep. Yeah. No, I'm just trying to understand where we are at with it. Cool, thanks.
The last one I wanted to mention was Thanos Compact. This is primarily for the ability to save us in billing costs. So it maintains a set of lifecycle rules. I don't think I linked directly to that, so maybe I won't be able to find that quickly, because I do think it's important for us to know that information. Is it in attributes? Thanos. Oh, perfect. Okay, so yes. So Thanos will actually reach out to long-term storage, so object storage, for metrics that are... Actually, it doesn't really tell me that. It modifies the resolution of our data based on these metrics. So for the past 1 year, we should be keeping every single metric available to us that we ever captured. If it's older than a year, we change the resolution of those metrics to 5 minutes. And I'd be curious as to what kind of algorithm it uses so that we're not severely hampering us, but I don't know how often we go back 5 years worth of data. Anything older than 5 years, we keep indefinitely, but it changes the resolution to an hour. So Thanos Compact will actually perform that operation. So it removes old data and modifies the resolution over the course of time. Thanos Compact also has the awkwardness that it needs to be the only thing running in that environment per bucket. So that's a singleton on purpose. It needs to remain that way, because otherwise 2 compact instances might run and bump into each other and corrupt our data, which is really fun to hear about. Back to the Thanos Query. In order for it to determine like which servers it needs to connect to. How am I running on time? I'm over on time, I'm sorry.
No, go for it. I want to hear this till the end. I still have
we have a helper file, just simply called generate inventory file. It uses it's not in this file, goodness. We use a chef search to figure out all the Thanos instances, determine which port they're running on, and we feed some extra data into it to determine whether or not that host is public or not. I don't know why we need this, and I don't know why we need that third item. But our chef search in particular, just to look at it really quickly, Thanos Query. Oh, where's the search at? Okay, so we look for anything that calls upon the recipe Thanos, whether or not the sidecar is enabled, and whether or not we have store enabled. I don't know why we need that in there either. But we're basically pulling every Thanos instance available out there and populating an inventory file that Thanos consumes. And it shows us every single box across all environments. Any further questions about Thanos?
No, thank you.
All right, so Trickster. This one is new to me. Trickster is a reverse proxy for Prometheus. So our dashboard's COM instance uses Trickster to communicate with Prometheus. It doesn't talk to Prometheus directly. We got a kind of a secondary win with this because Trickster is only configured to look at that specific application or infrastructure data for those environments. Where's that at? Here. So because Trickster is only configured to look at those Prometheus instances that live in these environments, dashboards.com will only have access to those instances. Trickster doesn't do much. He just sits there and proxies data between Prometheus and Grafana. That's all he does. Nothing super exciting. So if dashboards.com goes down, we know it's probably because Trickster is down.
And we use Trickster on dashboards.com, I assume because of performance, right? And
mostly, yes. It does some caching.
I think that's like, there's no reason for us to run it on .NET, I guess.
No.
No?
Because there's only 600-ish users hitting dashboards.net, whereas .com could have the public world bashing us because they want to know our uptime.
Right.
So Trickster's neat, but you know, it's a lightweight thing that's kind of new to me. So there's that. Any questions about Trickster? Okay. And the last thing I want to talk about was our third-party services. We use Pingdom to provide us external monitoring via some service that we pay for. We have a mixture of automated configurations that are generated and stored inside of our runbooks repository. We also have a couple of checks that are created by hand. We have a CI job that publishes any checks that we've got automated. Status.io is primarily just for advertising our state over the course of time. Our CMOC is responsible for setting that status. We have the link about this is here for that. PagerDuty is simply responsible for paging us. So Alert Manager will send alerts if they are high enough priority. We have the ability to send pages to people if we need to gather people's attention, but only, you know, if they've got accounts on PagerDuty. And then Slack is where we got a bunch of alerts that get sent to. Again, this is all configured inside of our runbooks rules repository. And we have a lot. We probably have, I think, 20 or so alerts channels. I highlighted the ones that I feel are the most important. So alerts is the bucket where like all the alerts just go to. Alerts general appears to be specific to a lot of the operational things that SREs are starting to pay attention to. So a lot of this work was done by Andrew. It also uses some sort of plugin, so we get fancy charts, we get little buttons that allows us to do fancy things inside of it. I think in general, that's what we want to migrate to in the future. But until then, because it's such a large thing to accomplish, the alerts channel still exists. Alerts G staging, specific for staging. CI/CD, they have their own channel. I'm actually not a member of. And then our abuse team, they have their own Slack channel as well. So this concludes my presentation.
This is awesome, Scarback. Thanks for doing this overview.
Yeah, it was really great. Thank you.
I'm really glad that you took some time to do this. And I think we should talk about next steps here.
Sure. Should I stop the recording for that or keep it
going? No. Keep it going. We want to, now that you're talking about the recording, first of all, you're going to have to upload this to YouTube.
Oh, okay? That has to be done manually?
Yeah.
Tell me later.
I'll tell you later about that. Second thing, I want to have this whole issue converted into an epic inside of GL Infra. You can use, I don't know, this major comment you made, but I know that you made a couple of other comments around this. So please organize it in such a way that, I think this way might be okay, per topic basically, where you are going to like put this again in the epic description and then start collecting the issues that we have, linking them to this epic. And then also you have a couple of open questions there. Yes. I want open questions to also link to issues. There are a couple of unknowns as well. So not just open questions, there are things that you just don't know there. Ask about those as well. What was the other thing that I wanted?
Probably documentation somewhere.
Correct, runbooks. Collect the runbooks that we have, collect the handbook items that we have related to this, and put it in one place and create issues that are going to be covering groups of things. So you don't have to go very granular on this, but for example, I don't know, describe Trickster, why, what, how, right? Describe Thanos, what, why, and how.
Yep.
And so on, right? So this is specifically for documentation. So specifically for documentation, you're going to apply on each issue documentation, and you can apply, I don't know, find the label. If we don't have it already, create a new one related to monitoring and alerting, maybe the two together, or two labels, monitoring, alerting, and put them together in those issues. And this is where we are going to stop. We, meaning delivery, are going to stop. So uploading the recording, so share it with the SREs, giving the epic to whoever is going to be looking into this. If that is us at some point, then okay. But for now, just have it written down somewhere. And then we are continuing with the work you started originally before you started looking into this. That should take you about 4 hours total to complete, in my humble opinion. So linking all these things together, uploading to YouTube and all of those things. So basically rest of today, you should take to clean this up. And then you're going to communicate this with the rest of the organization. So first of all, we have DNA meetings tomorrow. So put it in the DNA meeting Europe and afternoon, whatever it was called. Then obviously in all the channels. And then, I mean, when I say all the channels, I mean infrastructure lounge and production for now. What you can also do is, for curious people, just place it also in, cross-link it to development as well, because I know that we have some people wanting to know more about this. And finally, we do have our monitoring group, so they need to know about this as well. So go to wherever the monitoring group is in Slack and also cross-link to them.
The monitor, that like the team that works on the product, GitLab.com or GitLab product?
Yeah.
Okay.
Yeah, because I think they're going to be very curious to know about this, or they should be at least.
I wonder if anyone in sales would be interested, because I wonder if we have any large customers that would like information like this.
Possibly. I would, for now, I would just depend on product managers seeing these things and them thinking about it. I think that's not necessarily our task.
Gotcha.
So yeah, those are the couple of things I want to see as follow-ups. And then obviously once you complete all of those, in this issue, link to the recording, link to the epic, link to, well, you don't have to link to, just say that you placed a certain message, copy paste the message inside of issue, and then comment and close. And
Gotcha.
that's your work done. How does that sound? Awesome. Yeah, now you can stop the recording if you want to.